Hello.
Hey Jonathan, how's it going, man?
Awesome. It's great to see you. How are you doing today?
Oh man, I'm doing pretty good. I'm just chilling out and hanging out in my wonderful apartment. You're in a hotel, aren't you?
I
Like,
am, yeah. I'm in Santa Rosa at the moment. So I went up from Santa Clara on Monday, and yeah, so just heading into the office this morning. But I thought, I may as well record it in the room. At least I can control the light a little bit and maybe and the breeze and stuff. So it feels like forever, man. Especially the
yeah.
the Geckel stuff. It's been such a long time, and obviously the stuff what happened with those guys, and because where they were located, and it's been. So how are you doing? How's work? I love your name, Mike
Well,
Dakota. That's awesome.
well, okay. So, here's transparent Mike. So what happened is I think I told you. I got kind of moved off of one project I was on, of like data portal for NASA, but they
Mm,
kept me on the DC-8 project, which is really cool. That's going pretty good. It's kind of part-time, but
mm.
I picked up a gig with Boeing, and
Okay.
dude, I'm doing satellite stuff now. I'm doing ground software satellite, and I think we kind of touched on that last time we talked a little bit, because I want to talk about some satellite cool stuff and where that's going, the technology wise. And yeah, so they picked me up. Oh my word, Jonathan! It's so funny. It's like I get in there and they start talking about quaternions and Cartesians and magnitudes, and I'm like, huh? Because I'm a software developer working on documentation, right? And so it's so different now. I'm working with astrophysicists, and they are super smart. But it's awesome because it's a real challenge, right? I mean, I'm learning, and they keep me around. So I guess it's the Java skills that I bring, and then I'm learning the physics side of it. It's different because normally they have astrophysicists they train into Java programming. So it's
Yeah.
kind of a it seems like it's a new, I don't know, it's just a different method they're trying out. Um, it's going really good though. I mean, I've completed two projects already, but I have a really good guy I'm working with on the team. So that's pretty much about it. Enjoying the weather here in Palmdale. It's nice. And I'm sure, how's it up there where you are? It's real nice, right?
Yeah, it is. I know they've had a bit of freak weather around here, but as you were talking my mind's blown as always because
Oh yeah, yeah, yeah.
and it's interesting. So obviously, I think we one of the things what kind of triggered this was I was at Microsoft on Monday, strangely enough, talking about satellites, right, in a kind of
No
a
way.
small thing. So I was with Ruben, who was one of the first of the four designers of the original iPhone with Steve Jobs.
Wow. Wow.
Um, and so his entire team was there, and they were talking about actually. So I've got the iPhone 14 with the beautiful little notch, but it's got satellite on there, and then so I said, oh yeah, and obviously you've got talking to satellite, small data speed, and they said, oh, that was just the tip of what they wanted to do with satellite technology,
Wow.
which is to me is fascinating because yesterday I was in our Santa Rosa office, and the Keysight last year picked up a company called Scalable Networks.
Yeah.
Really cool, good company. I'll send you the link because if you just
Yeah,
watch
yeah, definitely.
the first video on there, they digitalized the battlefield, right? But they typically do network function virtualization and network digital twins, and that is for satellite positioning. Sending it to, what happens when people are DDoSing, or you're not able to, get direct line of sight for communications, and it's on nuclear subs and the whole stuff, and it kind of made me think very much like the Boeing. So I'm actually we were talking about that last night. We're
That's
talking about
crazy.
Boeing being, leaders in this space, and I've got,
Mhm.
in my back, I've got the Hololens, and part of the demo that I'm running in an hour to Sunchai, who's one of our big, leadership team, is actually walking around a kind of a fully, it's Atlanta Airport in real time, but all the planes are coming off, and you can walk around and interact with them. You can see the trajectory, And you can from a mixed reality perspective, you can just do that, and you're just kind of looking at it thinking, this is the future, right? This is
Yep.
kind of where we're going, where you're going. How
Yep.
in a way, space exploration is kind of
Yes.
leading all of this. I know
Yep.
today Elon's going to be talking about, he's on Jade Leno, right? And he's going to, are we going to become a multi-colony, citizenship? And it's so fascinating because I think the tech that's being driven is, and it's the same for the HoloLens. They delivered, I was talking to them on Monday, and they've delivered 5,000 units to the US Army, and part of that is that now you're in a tank. It doesn't matter if there's smoke, there's limited visibility, heavy rain. They can see perfectly, they can see everything
Crazy.
about their drones are filling in the gaps for all the GIS information. And you just think to yourself, it's like a superpower. And I think this is where technology is getting, is actually you're a developer, but actually you're a superhero because you're designing this next generation of, capabilities, which no one even thought was possible, right?
Yes, absolutely. That is so awesome because as you're talking, I'm thinking about, the Ukrainian war that's going on, right? And it's really awesome because these new technologies we develop, we can kind of hand them off to Ukraine and they can test them out for us. And so exactly theoretically, right, what you said, these new advancements that come out, they actually can use them on the battlefield. And I really like that what you said, because sometimes you all want to play a part, right? And what they're doing over there. And we kind of are. And so this kind of paradigm shift, call it more this satellite technology that's being developed, space exploration, it fills a gap for me, especially. I mean, don't get me wrong, I really love the aerospace, what I was doing, the documentation, the aircraft. But you heard about Sophia, they're kind of putting it in a box now. And right here, James Webb took over, right?
Yeah.
As you can see. So it's the satellites, it's that advanced technology that's really where everything is at now. And I totally agree with you, Jonathan. That's the direction that we're going.
Yeah, no, it's fascinating. Obviously, Gecko being impacted because they were
Yes.
based in the country, right? And I remember when it started. My friend Dan Oates Lee, he's actually a cyber reserve. So I used to work with him at GCHQ, and straight away he was over there with NATO, kind of doing cyber warfare defense, right? So making sure critical infrastructure's up, make sure people, the citizens are protected. So part of it is, even though by day, it was a black hat in Vegas a couple of weeks ago, and we're doing a webinar, a DoD webinar for the DoD modernization stuff in a couple of weeks' time. His day job is, security pen testing for companies, but then, he has to switch a bit like Anonymous or something and go straight in to help support, and protect. And I think that's the really interesting part, because you kind of said exactly the thing, right? Is, even though it's testing in the wild or testing in the battleground, it's turning the tide. The whole last week, they turned around and said, Putin's obviously not, admitting that he's kind of in a bit of a sticky situation, but the tech which has been enabling, we don't have to get involved, but the tech that we provide them allows them that differentiator that allows them to start taking back what is theirs, right? And so I think that's really impressive, because before it would be, casualties, right? And I think, we start with this idea that, like NASA, right, you want to, at the front of everything is the safety of the astronauts and the pilots. But part of that is the same thing, is it doesn't need to get to that point where it's more lost life, innocent life, or collateral damage. And actually what we do impacts that. And I think that's what's fascinating. And like the HoloLens, which sat with the guys, and of course everything's IVAC, and it's the entire headset is. And so it's a military command and control platform, right? But they coming to us to say, well, how do we test that, right? They test it in the field, of course, with people, but we're doing things like eye tracking. So we've actually got these little, we're scanning a human eye as they're using the headset, and then using OpenCV, we're seeing the positioning of the eye. And then we've got a Raspberry Pi, which is just replicating 2 LED screens to then be able to mimic the same action. So when we're running the automation, it's actually saying, okay, the head's completely still, but you're moving their eyes over to the right, so you have to pan the menus or the
Mhm.
the heads up information to be able to focus on that information. So, part of it is traditionally you might, just test the equipment in isolation, but when you put it all together with eye tracking, field of view, all that kind of stuff at high speeds, we did some similar stuff with the fighter jets for the US as well, where they can
Mm.
literally see through the floor of the jet, right? So they are flying. I guess Tom Cruise would have liked this tech in the new Top Gun, right? But you can
Right, right, right.
around him, right? And you
Mm.
think to yourself, this is it's crazy. It feels like the applications are endless. And we know that this goes in, and it was fascinating. I was in the executive center at the head office, and they've got the quantum computing stuff. So they've not got
Mm.
the quantum computers here. They've got them in, I think, in Denmark and a few other locations. But they were showing us what quantum computing would do for things like healthcare, military, and things like that. And it's fascinating because even the thought of bringing in things like quantum computing and even
Mm.
maybe even you in a few years writing Q
Yeah.
sharp, writing quantum algorithms, it just kind of blows your mind thinking this we never thought this was going to come in this time which we're here, and now it's the possibilities are as endless as the opportunities, right?
Yeah, it's so funny you said that because you said quantum. I go, oh yeah, I didn't even think of that one yet. I mean, the technology that we've built already is ready, right? And it's funny because maybe the next talk that we have, hey, dang, Jonathan, I got a new job and now I'm working with quantum computers or something like that. Because you're right, we haven't even touched that one yet. That's where everything is just going to explode, right? I mean, it's just mind-boggling. And when you said that, I'm thinking of a movie GI Joe or something like that. They have the thing on the eye and everything, and they're looking around and they're scanning the buildings and infrared going on and all this display, like a little, a heads-up display, like in their eye or something. You're describing it, right? I mean, we're
It's
living
like
in the
Universal
time.
Soldier, isn't it?
Amazing.
I think I'm going to ring, John Claude Van Damme and get him to start testing some of this,
Yeah,
do the
yeah.
splits, see what happens when you're wearing the headset. But it's interesting because literally, so I was, last night I was out with Gareth, who's our CEO of Eggplant,
Wow.
and I'm talking to him about a project we're doing. So we're doing a project called Ada, which is after Ada Lovelace, who was the first computer programmer. She
Mm.
lived and died just a few miles away from at one of our R&D centers. And so we've got this automation design assurance, what we're building a platform. And what the premise is to take what my friend Todd would always call exhaust data. So all these systems are generating huge amounts of data. And part of that data, which goes into terabytes, well, what do you do with it? And so
Mm.
partly, I was talking to him last night, I said, well, actually, if the quantum capability would give us that ability to take huge amounts of data,
Mm.
visualize it, and then run endless scenarios to be able to do what we're thinking about doing with predictive analytics and the
Mm.
normal kind of techniques within machine learning. Actually, you know, that would open up a new possibility because it would allow us to look at kind of the jitter in the data to say, okay, we're starting to see these patterns, something that would help people say, maybe things aren't going very well from a development perspective, or you're over testing, or actually you're seeing a vulnerability. All that information we don't look at. And we started off with log analytics, and then open telemetry and open tracing kind of capabilities. But actually, that next level of just, well, actually, if we've got 2,000 systems all talking to each other, we can
Mm.
take 2,000 systems data in pretty much real time, what we kind of refer to as multi-dimensional transactional data, take
Wow.
all of that and then just crunch it with something like a supercomputer.
Yeah.
Then you've suddenly got, you've got generation of tests, you've got generation of insights. And I think this is where maybe it's a new generation thing. Is they said data was the new oil. Big data was great, data visualization, but we were
Mm.
relying on data scientists and data engineers to really make
Mhm.
that happen. Whereas
Mm.
now maybe there's a bit of self-serve we can do on ourselves by building these platforms that harness all this data that we're capturing during development and testing, and then
Wow.
use it to provide next generation insights.
Yeah, speaking of next generation, so I'm teaching my son Java programming. He's only 14, And I am blown away at his grasp of the concepts. So thinking what you said, his generation will be ready for, I think, the paradigm shift, the technology change, because they're already grasping what we thought was difficult for us. And for them, it's nothing. And so, in fact, we're even be doing a project, as a science project, this AI project, where we're going to do image recognition for like this one place one is to count sharks, for example, in the ocean. They send you this video. A 14-year-old, are you serious? A project like this? So what you're saying, it's happening, and it's gonna be there, and it's like we're gearing our next generation, these youth, right? They'll be ready for it, and I think that because I can see it already with him, and even in his brother, the gaming that they're doing, Roblox or something like that. These kids are amazing right now, and it's like we're grooming them, getting them ready for the technology that you just mentioned.
You're absolutely right. Last week I was in Center Parcs with my family. My
Yep.
dad's 75th birthday, and my nephew's now 28. When he was growing up, I refer to him as the Xbox generation because he was, I'm still officially a millennial, but only by about a month and a half. But part of it is he was the Xbox generation, right? And when my sister used to say, "Well, where do you think you should learn his skills?" Right? I used to encourage him and say, Call of Duty, play this, have a go at this, because it's all this kind of critical thinking, problem solving, reflexes, all this kind of basic stuff that when you get into like a mixed reality environment, it's like Minority Report. You're pulling stuff out, people are doing it. They're not overwhelmed by the fact there's 5,000 objects on the screen. Whereas I think we was the generation, I remember, being back at university in the 90s, and it was like, I was doing Occam, which was distributed parallel processing code, but, I was doing it, but also then writing the maths behind it. And we were kind of told, here's how a CPU works, here's how the instructions work.
Right.
And it was such a level that, for us, we're restricted by the physics of it, and then Moore's law, right? Whereas now they're blowing through Moore's law, and they're saying, now, your son isn't asking, how does computer vision work to the point of, the individual pixels. He's just seeing it as, of course, I pick up, Spark ML or TensorFlow or some kind of computer vision, Google computer vision, and then suddenly I just train it with a whole stack of pictures of dolphins, and then it's able to recognize them, and that's, of course, it's fantastic. It's like whereas we would be like, well, this is overwhelming, right? This technology, I want to understand how all of these bits in the stack work, not that taking an open source, publicly contributed to project and then enhancing it. I think this is where we've enabled the next generation, like your son, to pick up something which is like Java, which kind of is extending his, again, superpowers to be able to just suddenly go in and do this.
Oh, yes.
And I think that's where we're at. But one of the risks, which I think is why I'm spending, I'm so excited about. I know it's probably changed since we last talked. Keysight, part of it is, Keysight is like the largest pure play testing company, and it's HP. So when Hewlett and Packard, were in the garage, all the equipment they were building, the test equipment is Keysight, right? So it's a kind of a spin-off HP. But in actual fact, that test equipment from back in 1939, which was given to Disney, right? And that produced Fantasia, the first ever stereo sound, which then, we've got Dolby Atmos and, all the vision and stuff now. Part of it is that journey, which feels like nearly 100 years, of evolving to the point of testing at the hardware layer. And, we're very much a hardware abstraction layer. If we know the software sits on top of it, software-defined networks, really it's kind of abstracting the complexity. However, when, and they were showing when I was at Microsoft, we were looking at the optics, down to 2 nano NM or whatever it is. And I was just sat there and they're looking at, the chips and how they build these next generation quantum processors. And you sat there thinking, wow, this is, again, we've got to test now all of the 7 layers of the networking stack, and for satellite, it's exactly that, right? Every single message counts. And that's why, of course, iOS 16, their ability to just line of sight to a satellite, you're able to send a message, but it's only a very small data payload, right? And I think,
Yeah.
Google, I think it was in 1997, did the first interplanetary protocol. They patented it. But again, it's like, well, are we going to be like that? Are we going to be like in our day, TCP/IP, and then IPX disappears, and now there's a new protocol, IP6, then suddenly just goes into, well, I'm just going to send a message to Mars, and then seeing a round trip of it. It's like
no problem,
no problem, right? And the guy, the Microsoft guy, was sat talking to me during the break, and he said, we realized we finally did, cracked it when we were able to play table tennis in real time with someone in Japan, because the latency has to drop down to a point where you can physically hit it, and then within less than 200 milliseconds, somebody can hit it back. And you're just kind of thinking to yourself, this is a whole new challenge of networking. The stuff I was doing yesterday, we were looking at the first 6G wave. So, 6G, higher frequency, massive more amounts of data availability and reduced latency. That then gives you this kind of capability to start thinking about large amounts of data being sent. And I think this is why what you're working on is incredibly critical, because satellites enable this. The Skylink kind of viewpoint of you now can communicate from anywhere in any environment. That technology will be the same once you see things like the Google and Apple glasses coming out in 2024. We will just be wearing them as normal, regular glasses, but they'll embed something like the new 3GG standard for 5G. So release 17, which is going to have this ability to do ultra fast, data for when you're walking around the street, and it's pulling information. It's doing, computer vision on facial recognition of people, and he goes, oh, you want to see Mike? He's just round that corner, and you can see through the wall, right? And you kind of then
please don't
and have a beer with
please
you.
Don't see me through the wall. Sorry,
but that's the tech which is going to be there, and we just think to ourselves, it's more than just Minority Report this, or anything that we've even dreamed about as in the sci-fi landscape. If the Terminator had this, Sarah Connor would have had no chance, right?
Yeah, no joke, man. We'd be all doomed. That's crazy you say that, because those kind of glasses will be amazing. I mean, think right now about, I'm on the web, right? And I'm or even on Amazon or something. All of a sudden he goes, hey, maybe you want to order this. And I'm like, how did you know that? Or you get on one of these other sites like YouTube or whatever, right? And like in my car, I'm sitting there. Now it knows I like to go to this one poke place. I get in my car and it knows. And it also knows, like, oh, you ready to go home now? So it's like that whole AI thing. Now you pack that into those glasses and you say you're walking around, and that's a whole bunch of information that you be parsing. It's available to you. That's crazy, Jonathan.
I know, and I think Car2X and Infrastructure to X is really interesting as well. So another one of the demos we were doing, because we've got the board coming in tomorrow, and the from Intel and all sorts of other specialists in the area, and part of it is I was at CES in January. We'd launched this emulator, so a vehicle, autonomous vehicle emulator, which pulls up this ability to map on millions of objects. So instead of driving down a street and they're simulating a car being there, it's simulating a bird flying across, or something blowing some shrapnel across or something. They can run these incredibly complex simulations, and now car manufacturers are using them so they can know to auto brake, but also we've got something called a B, which is like a vehicle to X. So there's a car driving round the corner fast, completely not visible, but your car, as a Car2X, vehicle to X, is talking to that car. And even though you can't even see that car yet, it's coming down and you're braking because you know that he's potentially run a red light. And so you're thinking to yourself, okay, well, this is, incredibly critical. It's critical that it's not only autonomous. You really need to be able to be connected. And then if you think about connected, and then you think of that space, then, and this is what the guys were saying yesterday, is like, it starts at 500 meters, then it starts at 5 miles, then it's 10 miles, then it's 100 miles. Then you've got all of this information to kind of model, the smart cities of the future. And these smart cities are, turning traffic lights green so that the lorries can go through, which are completely autonomous in their own lane, don't have any chance of causing any kind of issue, but also maximizing the carbon footprint for that journey. So part of it is seeing these applications, whether it be transportation, connected car, infrastructure to X, and it's all enabled by what we would have, got excited about, the kind of IoT boom. But now, the guys at Microsoft, they showed this demo where it's like all the IoT sensors are there, and you literally now it sees something wrong based on, it's learning over time that the tolerance within one of these reactors or something is slightly off. And then you see someone walking over to it and, being able to see the digital twin of the entire thing and look at this one component that's within the reactor that's not performing correctly, and then, literally interact and then turn it down, try to resolve the issue on that one component until it becomes green, and then they're off. And that means that in theory it could be anywhere, right? And that was the Microsoft quote was, today, here could be anywhere. So you don't need to be, stood next to a nuclear reactor. You can be a digital workforce in any part of the planet, all collaborating and working, fixing infrastructure, and working on digital twins. Even, they did a surgery from London Child Hospital where they managed to actually cut two connected children, babies that had come out. They actually did the remote surgery from London to this remote location using twins to actually, to do surgery. So, you're getting to that point where we're doing 6-directional robotics where literally they can, in essence, emulate exactly what the surgeon's doing to that kind of perfect thing with haptic feedback, so they know that they're interacting and touching something. It's just, my mind is blown continuously all the time.
It's so funny you mentioned that, because I'm sitting here listening to all this and parsing it, and I'm thinking, wow, we're saving lives, we're saving time, and like you said, we're saving our planet too, right? You said the carbon footprint. Our technology, some people may be afraid of it, right? But it sounds like it's very beneficial, and everybody's kind of pitching in, right, on this whole new technology, I don't know, whatever you want to call it, expedition. And then so what we're doing is we're looking in and we're saying, wow, this is changing our society. A smaller example is my aquarium, where it's this coral reef tank. It's doing really awesome, but I got it automated now, right? I got a doser on it. And I can be anywhere in the world and go, oh, I need to add, I don't know, this chemical or that chemical, or, oh, it needs salt. Oh, let me add some more of this to it. So everything is becoming automated, and everything's becoming more precise too. Anyway, so I find that really fascinating.
It is fascinating. And the whole point is that everything's now connected.
Yes.
You're doing more with less. The idea is that, you're not killing a whole, reef because, you put the wrong amount of chemicals in, right? It's part of it is there's an AI there, or maybe some algorithm that's saying that's too much. This is how you get your pH level up.
Yes.
Kind of an issue before it, impacts the fish. And, I think, thanks for all the fish and Hitchhiker's Guide to the Galaxy kind of quote there. But, part of it is, it's fascinating, but you're absolutely right. It's also planetary. It's saving the planet in the sense of the carbon footprint of you going, oh no, I need to go back to my house and feed my fish. That's detrimental for the planet. But also, as you said, like the digital workforce that are coming together from, every part of the planet that can all work together. The greatest minds can work together. And, I'm speaking next month at Star West, but about 8 years ago or maybe it was 9 years ago when I spoke there, I had this big slide which said, it was 2012. So I said, in 2012, there was 212 years spent just people reading emails per day in the US, just the US, right? So what have we managed to achieve in 212 years? What happens if we had all of that time back to, in a kind of a Star Trek way kind of thinking of boldly doing, moving citizenship forward, our technology and our evolution forwards. If we had all that time back, and I think that's what we're doing, and I think this is where like the new generation is seeing is that everything I refer to it as like the digital grind, but actually it's the amount of digital interactions are reduced. We used to, want to download some music, we'd go to Napster, we'd then, connect our MP3 player, plug it into into it, download the file, plug that into our car to then play the music. Now it's just, it's streaming, whether it's, Spotify or something, and it's within 3 or 4 seconds of what you're saying, it's done, right? And I think that's showing the kind of progress we're making. The technology in a way is still the same, but in actual fact, the amount of interactions required is so much smaller. Therefore, you're freeing up more time. And I think if we can get to that point, at that point I said ban all email. But if I got rid of email and I woke up this morning, and because I'm in different time zones, 400 actionable emails that I did. Really, I wanted a digital twin of myself responding to 90% of those. And then the 10%, which is stuff that I need to do, would then straight go onto my to-do calendar, which is what, is already kind of happening with Outlook. It's reading your event. Someone says, hey, let's go, have this Zoom call today, and it then adds it to your calendar. It adds it to your to-do list. Once we've had the call, it removes it. We had to reschedule. It auto reschedules. It checks your Calendly, checks my Calendly. It works out the next best slot. And all this stuff is getting closer and closer to the point that it's seamless, and takes away that kind of, I guess in the old days, we'd page somebody and then that one message would page back. But if you think about what we're doing now from a communication, it's taking all that off. And there was a recent study in Cambridge where they talked about, if you could create a digital twin of yourself, and it could work for 5, 10, 15, 20 different companies at the same time, bringing what you have to the table. And this could be your son. And there was a scary statement Ruben said, because he was one of the original creators of the iPhone. He said, we're the last generation to die. And I kind of, we was like, okay, this is a bit morbid. But what he was trying to say is that, a bit like Upload, if you've seen the series on Amazon, is we'll be uploading ourselves, our transcendence will put our consciousness will be then part of a metaverse and will live on, and we, forever. Now you may say, well, it's just completely crazy, and it probably is. I think it's probably a little bit too far, but it's interesting that the idea now is saying, well, actually, if you're getting to that point where the work that you do can help hundreds or thousands of people, at what point does money doesn't really exist anymore? Part of it is very Star Trekky, but that idea that actually it's we're all doing something for the greater good, and that actually you're rewarded by your contribution and your critical thinking and how you can help, whether or not you're a developer, a tester, or you're in different industries or whatever it may be, healthcare, military. And there's so much more crossover and share of technology, share of IP and thought process. And I know Elon's done this with the battery technologies and all the other stuff. He's really focused on, well, how do we move everyone forwards? Even things like Neuralink, which he's now investing in the competition because he wants people to get to that point where they can connect their brain to the system and then do it to help solve medical issues, but also to kind of engage us into a new landscape. A bit too matrixy for me. I feel like if I had it would be version 1, and it'd be like a COM port versus a USB port. I'd be sat there going, God, this data is so slow, and then you turn up with the V2 version, which is like 4 terabytes per second, and I'd be like, I need to upgrade and pull this giant thing out of my brain and stick something else in. But I think maybe it's going to be a few more of these podcasts before we get to that point. But
I hope so, John. This is awesome. But it's really funny you say that, because my son's already going like, wow, this is slow. I'm like, are you crazy? You have a super fast computer, and they just want the speed. They're just so used to it. And back then, remember, okay, I'm dating myself. Remember dial-up modems?
Yeah.
We haven't even gone there. Whatever, right? And it's like, okay, I'm waiting the baud rate. I'm waiting to download whatever this says on this bulletin board. Are you kidding? These kids today, they would probably throw away all of their phones or whatever devices they've got because they don't have the patience for it now. And the thing about it is they're demanding. And I was kind of curious about that too. It seems like all of our technology is moving in that direction. Like you said, big data, the network, everything is moving in that direction for exactly what Elon was saying. Because it's like we're gearing ourselves through all these advancements, through everybody kind of pitching in to get us to whatever that paradise or whatever they want to call it is. So that's crazy.
No,
I mean, 10 years ago, we think I'm crazy, but yeah.
It's exactly, I remember, my first CompuServe kind of, thing, and it was literally, dial-up modem, it was a 28K flex, and it was a dedicated line to, and it was $1 or $2 a minute, you had to get on there, which, it's first connecting, and then you get into your news group, or you're wanting to get the information you want, and then you want to come off as quickly as possible. And it's like that whole process might have been 5, 6, 7 minutes, could be an hour, right? Part of it is we had to be tolerant about this, whereas I think the tolerance levels change. And what I think is fascinating about this is that it's instant gratification, right? Part of it is they want the information straight away, right? They, whether or not they're looking at TikTok, and saying, well, actually, I use TikTok because I can find updates about, the Queen's funeral. When you just sat there going, well, why don't you look at the BBC or read a newspaper? Like, what kind of, technology is something that gets printed off and is a day behind? They want it as it's happening, as someone's walking up. If they don't get that, they, as far as they're concerned, if it's not coming to them within 30 seconds, it's way too long for their kind of attention span and information. But what I think they've traded off, which I think is really hard for us, and I think it's personally really hard for me, is they're also more tolerant with technology in the sense if it crashes, there's an issue, they oversee it as long as they get what they want, right? Whereas we used to see and NASA quality, right? The idea is we want to engineer quality because we want the best quality product, whereas they want the product with the capabilities at the lowest price, which does exactly what they need. And that's where suddenly I think it's changed, because we look at things differently. We want to engineer the best quality product. They want just the product, right? They want the product today, whether it's DevOps, continuous delivery. They want the feature tomorrow, right? That's what they want. And if they don't get it, they're not going to wait 6 months, 12 months for someone to design it, build it, and implement it. And if they have they're an early adopter in essence. If you were, looking at, the product life cycle and Geoffrey Moore's kind of Crossing the Chasm, they're all stuck in that earlier adopter mode where they're so much more tolerant, whereas we were that kind of early majority, late majority who were, or even the laggards who were like, well, actually, no, some people were like, I don't want dial-up because it's too different. But, it was only 5 years ago when I remember looking at some analytics, and there were people in New Zealand using dial-up still, and you sat there thinking, how is that even possible, right? And it's kind of that area, or you sending people fax machines, it's just craziness, because people are just like, how did you do that? You had a dedicated line with a printer to print off and send messages, but over fax. It's like, it's crazy. And I think that's the thing. If we give them the technology, and I think this is the big thing about mixed reality, is that when Google and Apple launch these devices, and everything from the Play Store and the App Store just becomes part of their glasses, we're all walking around with these devices, and looking, at them and not looking at other people, right? Because, we're trying to get the data, the metaverse, and the information we want and be connected, but also interact with the real world. But if you've got those on there, just some glasses, you're getting the information that you need. You're interacting with people normally. You're not, walking off onto the road because you're paying more attention to your device. And I think that will be a big change for a lot of our generation. The idea of not using a phone, which they've only just kind of digitally been able to start using, to shift to the point where the phone's gone, all the processing's done at the edge, or it might be in the cloud. There is, I don't buy this gigantic TV behind me because I just pick it up as an NFT with Samsung and I just wang it on the wall, and I've got 1,000-inch, screen, and I'm on the plane, I've got a 1,000-inch screen.
Wow.
It's kind of that point where people won't buy certain things because, that is a physical piece of hardware. And if I want the new 8K, capability or HDMI 2.1, I'm going to have to recycle that and pick up another device. And that throwaway economy that we kind of got used to because we got a 14K modem, and then we wanted a 28, then we wanted a 56K, then we wanted a DSL 128 bits per second kind of dedicated. We want to upgrade it, like you said about the ultra fast computer. Is we got to that point where we're looking at it going, oh my god, this 286 to 386 is a huge difference. I've now got a maths code processor. Probably know what to do with the maths code processor. Then it was like, oh, and everything's doubling every 6 months, and we're like, we need this latest tech because now we've got 4 meg RAM, we've now got 8 meg RAM, and then now it's I've got 32 gig RAM on my laptop at the moment.
That's nothing. Yes.
And I've actually got behind me, I've got a Stream Deck, right? And the Stream Deck has 16 gig of memory, and it's got a full-fledged gaming GPU that would rival an Xbox generation, right?
That's
you sat there
crazy.
going, it's this big.
Yes.
If that's now in here, and maybe I'm even using Azure's compute power to do those GPUs,
Yes.
then we're not even going to have devices. We're not going to have laptops. We're not going to have, mice. We're not going to have all these things that we've grown up from the 80s or whatever, thinking, wow, look at this device that I can put my hand on and move around. And now you just do a bloom gesture and then you just interact with it. It's crazy, and I think that's what this entire episode really is. It's this kind of, this is a new world, right? This is a completely new world. But as we go through it, we have to, back to Hewlett and Packard's garage, is we're building it and testing it, building it and testing it. And it's just a continuous iterative approach. And to allow us to test and to allow us to build, we need developer, kits with the latest and great stuff. We need testing kits that give us everything we need to test the hardware, the software, the network. We can't leave any of that stuff behind. People just kind of got obsessed with UIs and like, oh, I'm going to automate that UI, or I'm going to create a UI, another web page, or another kind of thing. You think to yourself, you've got to stop thinking like that. To be honest, I think everything's just going to be a node in the future, and it's not going to have interfaces. Those apps that we have at the moment with a UI, that doesn't really exist in the metaverse. That the data is then visualized in a common framework, and whether or not you're making a phone call or you're having a Teams call, or we were talking about Mesh as well yesterday, where they're just saying, well, yeah, we don't leave anyone behind. So if you've got the old mixed reality or virtual Oculus headsets, you're joining in like Meta workspaces, and then someone's coming in with a mixed reality headset. They've got an avatar representation of themselves. You've got a physical rendering of yourself that's coming from a stereo camera that makes you look like you're, again, off the Minority Report, as a hologram, or Obi-Wan Kenobi, you're in my only hope. You're going to get that kind of thing where you just everyone just comes in, and there'll be somebody who's dialing in with their laptop, and they'll be an avatar, but not with the same capabilities as everybody else. And then people will be thinking, I'm missing out. It's like a FOMO of missing out of this digital kind of new metaverse. And then last night we were having a few drinks, and I was kind of trying to say about Web 3.0, getting rid of the old Web 2.0. Oh, I'm going to go and look at Intel.com. Part of it is decentralized. We've seen all the blockchain and the values of crypto and crypto wallets with NFTs and all this kind of stuff around, taking away some of that kind of old infrastructure. And I think that's going to be the future, is that it's all going to be decentralized, and the data is going to be feeding in. And if I want to learn about Intel's new chip, that information will literally be a digital twin where I then overlay it and I can see it, and I can try that chip with my technology, what I want to do. I can experiment with it. The information goes back to Intel because it's an emulator or a simulation of this new system that I'm building. And then only when necessary, the physical hardware is then printed off, 4D printed off, and then sent in to build these custom devices that's going to be on a boat or a satellite. And people are just sat there thinking, well, no, that's just not how we used to do it. We'd have a circuit board with manuals and soldering irons, and and that's how we build stuff, right? And it's just going to be, the kids today are going to be like, oh, well, what happens if I stick this quantum computing capability and I mix it with this and this, and it just goes, a bit like Iron Man, right? He's going to be running the permutations till it literally says, you've invented time travel, right? And you'll just be like,
yeah, right.
Awesome. As Joe always says,
Wow.
he calls me the automation cyborg sent from the future to save the world from bad software. I will literally be able to send myself back to my 90s version of myself and say, here is the framework you've been looking for. Maybe drop it in a few floppy disks or a zip drive, and then he'll just be like,
what's that? Right.
So I think that, well, if I can find somewhere that has some 5 1/4 inch floppies, then yeah, or even some punch cards, right?
Wow, what's that? That's back my dad's IBM days, and he said we used to take punch cards and make little castles out of it. Now, I mean, that's crazy. Wow, that's so interesting. I just think about all of that, and I was thinking, like, I remember when I used to go with my grandmother and watch the people at NASA. It was at Johnson Space Center, and go, wow, those are the people that are really doing the cool technology. But when you're describing, everybody can now. It's like everybody has that ability. I mean, to go on Amazon and order whatever that device is, and they can play with it, like a Raspberry Pi. I mean, that's even old school now. I mean, things are becoming like where anybody, if they just want to do it, can get pitch in, or they can come in and they can just participate. It's a crazy society now. I mean, there's no need to be like a specialized scientist anymore. Everybody has that capability, especially with AI and the advancement and all the data that we're collecting. Anyway, that's a super cool thought.
I think we're going to leave on that super cool, because Gareth just messaged me. We're heading into the metaverse again for another run. So, I'm looking forward to getting this one out. But I think we should set up some kind of monthly kind of
let's do it
where we just keep on do it in, and let's get it. I got to about 1,000 YouTube followers, and maybe we could just keep on blowing this up and just till people realize the tech, and we'll share some some links that we've talked about, and let's make it a regular thing, man.
I do. I agree, man. I love it, Jonathan. It seems like every time we get together, you and I just go everywhere. There's always that particular theme about how technology is and where it's going. I am so down for this.
Perfect.